Hello everyone, I am Dr. VRAO. Today I am here with another concept in electrochemistry, that is concentration cells. Concentration cells, right? In order to understand the concept of concentration cells, we have to recall the concept of electrochemical series, right? Electrochemical series, and that series starts with lithium and ends with fluorine, right? And this is electrochemical series. In this series, in this series, hydrogen, it has reduction potential is 0, hydrogen reduction potential is 0, and these are the electrodes with negative SRPs, and these are the electrodes with positive SRPs, that is positive standard reduction potentials. So, with the help of this electrochemical series, we can construct a cell. We can construct a cell by taking one electrode with a negative standard reduction potential, usually which acts as anode, and one electrode with a positive standard reduction potential, usually it acts as cathode. So, by taking one electrode with a negative SRP and one electrode with a positive SRP, we can construct a cell. We can construct a cell. For example, we with the help of zinc, if you take zinc electrode with zinc is with negative SRP. So, the electrode with the negative standard reduction potential acts as anode, and if you take copper is with the positive standard reduction potential, so it can act as cathode. So, with the help of zinc and copper, we can construct a cell, that is Daniell cell, that is zinc. In usually the electrode which acts as anode undergoes oxidation, and the electrode which acts as cathode undergoes reduction. So, zinc and Cu plus 2 Cu. This is the way of representation of a cell. This is called representation of a Daniell cell. So, Daniell cell is represented by like this. So, in this zinc undergoes oxidation and copper undergoes reduction, right. So, with the help of electrochemical series, we can construct any cell like like Daniell cell, but we can construct. So, in the construction of this cell, we use two electrodes, that is two metals. So, with the help of two electrodes, we can construct a Daniell cell, right, Daniell cell. But there are another type of cells, that is concentration cells, that is we can construct a cell with the same electrode. We can construct a cell with the same electrode. That type of cells are called as concentration cells, right. So, usually we can construct a cell with electrode with the negative SRP and electrode with the positive SRP. By combination of that two, we can construct a cell. And moreover, it is very important point that should you keep in your mind, that is we can construct a cell with the high EMF. We can construct a cell with the highest EMF by the combination of electrode with electrode, by the combination of electrodes whose potential difference is high, right. For example, in the Daniell cell, we can construct the Daniell cell with zinc and copper. Its EMF is 1.10 volts. 1.10 volts. Of course, we can construct the cell with great highest EMF. How can we construct a cell with highest EMF? By the combination of two electrodes whose potential difference is high. That is, we can construct a cell with lithium. Lithium is on the top of the electrochemical series. Lithium is on the top of the electrochemical series, and it has a least reduction potential minus 3.04. And we can take another metal, that is it is for your understanding. So cobalt. Cobalt is a metal with positive SRP, that is whose potential is whose reduction potential is 1.1, and we can construct a cell with the combination of lithium and cobalt. Then what would be the EMF? EMF is nothing but difference between the reduction potentials, that is 1.1 minus minus of 3.04, minus of 3.04. Therefore, 1.1 plus 3.04, that is 4.05, that is 1.1 and 0.4, that is 4.14. So, we can construct a cell with the highest EMF by taking the combination of two electrodes whose potential difference is high. Whose potential difference is high, right? And now we can also construct a cell with the help of a single electrode. We can also construct a cell with the help of a single electrode. If we construct a cell with a single electrode, that is called concentration cell. That is called concentration cell. Okay. So, concentration cell is the cell in which electrodes are that can be constructed with the help of identical electrodes. There is no need of two electrodes in the construction of concentration cell. So, concentration cells can be constructed with the help of identical electrodes, that is single electrode, one type of electrode, right? And this concentration cells are two types. Concentration cells are two types. Concentration cells are two types. One is electrolyte concentration cell. Electrolyte concentration cell. And the second one is electrode concentration cell. Electrode concentration cell, right? So, let us go through the electrolyte concentration cell first. Then later we shall go through the electrode concentration cell, right? So, electrolyte concentration cells. Electrolyte concentration cells. In this type of cells, two identical electrodes are dipped in a solution of electrolyte of that is in this type of cells, two identical electrodes are dipped in electrolyte solutions of two different concentrations, right? Two different concentrations. For example, let us consider the one electrode. Let us take one electrode from this electrochemical series. For example, if you take a zinc electrode, so we can construct this electrolyte concentration cell with the help of a zinc electrode. With the help of a zinc electrode, so we can in this type of cells, the two electrodes are with the the two electrodes are identical electrodes. The two electrodes are identical electrodes. So, in this electrode, anode is zinc and cathode is also zinc, right, but that two electrodes are dipped in two different electrolyte concentrations, two different concentration of zinc sulfate concentrations, right, two different two different concentrations of zinc sulfate, and the EMF of the cell is produced due to the diffusion of electrolyte from a solution of electrolyte of high concentration to low concentration. Okay, I repeat, electrical energy in electrolyte concentration cells, electrical energy is produced due to the diffusion of electrolyte from a solution of high concentration to solution of low concentration. So, due to diffusion of electrolyte from high concentration to low concentration, electrical energy is produced. Therefore, whenever the two electrolytes concentration becomes equal, cell potential is 0. Therefore, initially, that is at start, EMF of this cell is more, and gradually the EMF of the cell decreases to 0, right. EMF of the cell decreases to 0, right. So, initially initially EMF of the cell is high, gradually EMF of the cell goes on decreasing and reaches to 0. When it reaches to 0, when that two different electrolyte, that is when two different concentrations of same electrolyte becomes equal, then the EMF of this cell becomes 0. So, it should be kept in your mind that in concentration cells, initial EMF of this cell is high, but in due course the EMF of this cell goes on decreasing and it reaches to 0. When this reaches to 0, when that EMF of the electrolyte concentration cell reaches to 0, whenever the concentration of electrolytes are becomes equal, right. So, let us go through the example of electrolyte concentration cell. Electrolyte concentration cells, in this electrodes are same, that is let us consider the zinc electrode. So, zinc electrode acts as anode. We know that electrode with negative SRP can act as anode. So, here the zinc electrode is taken as anode. Zinc undergoes oxidation, but zinc is dipped in Zn+2 solution of concentration C1. And here the cathode is also, what is the reaction undergoes at reaction takes place at cathode? Reduction, that is zinc again undergoes reduction, that is Zn+2 concentration here is C2 undergoes reduction. Okay. So, same electrode, zinc undergoes oxidation here and zinc undergoes reduction here. But zinc, here you should note this point, here the anode is zinc electrode and cathode is also zinc electrode, but that zinc electrode is dipped in Zn+2 solution, that is zinc sulfate solution of concentration C1, and here the zinc electrode is dipped in a zinc sulfate solution of concentration C2. So, these two are two different concentrations of zinc sulfate solution, and EMF of this cell is, and electric energy is produced by this cell is due to diffusion of electrolyte from high concentration to low concentration. So here in concentration cells diffusion takes place. It takes place from high concentration solution to low concentration solution, right. So initially the EMF of the electrolyte concentration cell is high, and in due course whenever the two concentrations are becomes equal, the EMF of the cell would be 0. Okay. So let us consider the another electrolyte concentration cell, that is okay. Another electrolyte concentration is the platinum Cl2 gas 1 atmosphere, put in Cl minus ions of concentration C1 and Cl minus of concentration C2, put in Cl2 gas 1 atmosphere platinum, right. This is another example for electrolyte concentration cell. Here the platinum chlorine electrode, okay, platinum or chlorine electrode, here this anode is or platinum electrode, or here the anode and cathode are same. Here the cathode and anode are same, but this cathode is this anode is dipped in solution of Cl minus ions of concentration C1, and the cathode is dipped in solution of Cl minus ions of concentration C2. Okay. So this is the electrolyte concentration cell which is reversible with respect to cation. So this is the cell and this is the example for electrolyte concentration cell reversible with respect to positive ions or cations, and this is the cell, and this is the another example for electrolyte concentration cell, and it is reversible with respect to the anions, right. These are the two examples for electrolyte concentration cells. Now we shall take one of this cell as an example, and we go through the let us calculate the EMF of this cell. Okay. So let us consider this zinc this cell as an example for electrolyte concentration cell. In this cell electrode is reversible with respect to the cation. In this cell electrodes are reversible with respect to cations. Electrodes are reversible with respect to cations. Usually what happens at anode, let us go through the EMF calculation of this cell. Okay, what happens at anode? At anode oxidation takes place, that is zinc undergoes oxidation, that is Zn plus 2 of concentration whose concentration is C1 plus 2 electrons, right. And what happens at cathode? At cathode zinc undergoes the same zinc electrode, that is concentration whose concentration is C2, and 2 electrons gives rise to zinc. This is solid, of course, this is solid, right. So net cell reaction is 2 electrons get cancelled. Okay, zinc cancelled, and Zn plus 2 C2 gives rise to Zn plus 2 C1. This is the net reaction of this cell, net reaction of this cell. So net reaction of this cell. Okay. So now let us calculate the EMF of this cell. EMF of this cell can be calculated with the help of Nernst equation. What is Nernst equation? E cell is equal to E naught cell minus 0.059 by n, where n is number of electrons transferred, log k. K means equilibrium constant of the reversible cell reaction. Okay, reversible reaction that takes place in the cell, right? So concentration of C1 by concentration of C2, because this is the reversible reaction, and K can be written as concentration of products by concentration of reactants. That's why I write C1 by C2. Okay, C1 by C2. Okay, and one most important point in concentration cells is in concentration cells E naught cell is 0. E naught cell is 0. Why E naught cell 0 in concentration cells? Already we know that E naught cell means standard EMF of this cell. Standard EMF of this cell, that is the standard EMF of this cell can be calculated as E naught cell minus is equal to E naught oxidation potential plus E naught standard reduction potential, that is standard oxidation potential plus standard reduction potential. So E naught cell, we know that E naught cell is equal to standard oxidation potential plus standard reduction potential. Here the oxidation and reduction, same electrode undergoes oxidation and reduction. For example, if you take this zinc electrode, zinc undergoes oxidation. Due to the oxidation, what happens due to the oxidation of zinc, for example, X volts is generated. X volts is generated, and the same electrode undergoes reduction, So what is the electrode potential for reduction? It is opposite to the oxidation potential. It is opposite to the oxidation potential. Opposite to the oxidation potential means you just change the sign of the potential. Okay, so due to the oxidation of zinc, X volts generated, and due to the reduction of zinc, same quantity of potential is generated with opposite sign. So this is called E naught oxidation potential, and this is called E naught reduction potential. Let us add that two potentials, that is E oxidation potential is how much? X volts, and E reduction potential is how much? Minus X, then is equal to 0. So E naught cell is 0 in concentration cells. Why it is 0? Because same electrode undergoes oxidation and same electrode undergoes reduction at standard conditions. So when we add that standard oxidation potential and standard reduction potential, E naught cell is 0. So what you should keep in your mind is that E naught cell is 0 for concentration cells. So we can take E naught cell is 0, E naught cell is 0 minus 0.059 by 2 log C1 by C2. Therefore, E cell is equal to minus 0.059. Okay, let us write this equation in a universal manner, that is actually when we write 2, when we confines to this cell, but in general we write n. Okay, in general we write n instead of 2. Okay, log C1 by C2. Okay, C1 by C2. So this is the equation for calculating the EMF of the electrolyte concentration cells. Okay, let us see the different cases of EMF of the cell of electrolyte concentration cell. Okay, let us see the different cases of different cases in the EMF of a cell of a electrolyte concentration cell. Okay, case 1. Case 1, I already told you in concentration cells, initially at start, at initially actually electrolyte concentration cells, electrical energy is produced in electrolyte concentration cells due to diffusion of electrolyte from one concentration to another concentration, that is high concentration to low concentration. So, at start or at initially EMF of this cell is high and gradually it decreases to 0. When it decreases, when it is comes out to be 0, when the two concentrations of electrolyte becomes equal, and the two concentrations of electrolyte are equal, that is case 1 is when C1 equal to C2. So, concentration of C1, you know C1 is this the concentration of electrolyte in the anodic chamber, and C2 is the concentration of electrolyte in the cathodic chamber. Okay. So, anodic compartment or cathodic compartment, C1 is equal to C2. When C1 is equal to C2, that is 1 by 1. For example, if you take C1 is 1 and C2 is 1, 1 by 1, that is 1. So, log 1 is 0, then E cell is 0. So, when the concentrations of two electrolytes and the concentrations of electrolytes are equal, E cell is 0, right? E cell is 0. Now, let us consider the another case, case 2, that is C1 is greater than C2. That is concentration of electrolyte in anodic compartment is more than concentration of electrolyte in cathodic compartment. C1 is greater than 0. For example, C1 is greater than, I shall take C1 as 100 to make it is clear. C1, I shall take C1 is equal to 100 and C2 is equal to 1. Let us calculate E cell is equal to 0.-0.059 by n. C1, that is C1 is 100 and C2 is 1. Okay, now we can write this 100 as 10 square by 1. Okay, minus 0.059 by n. So, this can be we can drag this 2 to the front, that is minus 0.059 by n 2 log 10. 2 log 10. Log 10 is 1. Log 10 is 1. Therefore, which comes out to be, we can get the product of 0.059 into n by n, right? Okay. So, this E naught cell comes out to be negative value. E naught cell value comes out to be negative value. Okay. But E naught cell is in relation with delta G, that is free energy of the cell. Actually, free energy of this reaction, free energy of the redox reaction is converted into electrical energy. So, this electrical energy is in relation with delta G. What is the equation for delta G? Delta G is equal to minus NF E cell. Okay, NF E cell. So, E cell is negative when C1 is greater than C2. That is what, let us calculate delta G, that is NF E cell, that comes out to be negative, that is negative E cell. So, negative into negative, positive NF E cell, NF E cell. Therefore, delta G value is positive. Okay, when delta G is positive, then that reaction is non-spontaneous. We know very well that delta G is positive, that is a non-spontaneous process, right? Right. And the case 3 is Case 3. Case 3 is when C2 is greater than C1. When C2 is greater than C1, that is I shall take C2 is 100 and C1 is 1. Okay. Now, we can write this E naught cell is equal to minus 0.059 by n 1 by 10 square, 1 by 10 square, that is we can write 100 as 10 square. Now, in the next step minus 0.059 by n log if you take this is the numerator, and we can drag this numerator to denominator to numerator, that is 10 power minus 2. 10 power minus 2. So, this minus 2 and this minus and this minus, therefore, that is positive. So, therefore, E cell comes out to be positive. E cell comes out to be positive. So, when E cell comes out to be positive, what is the change in delta G? What is the change in delta G? Delta G is equal to minus NF E cell. Okay. So, minus n F E cell is positive. E cell is positive. Therefore, delta G is equal to minus NF E cell. Okay. So, delta G comes out to be negative value. Delta G comes out to be negative value. When delta G is negative, that reaction is spontaneous. Okay. This reaction is spontaneous when it happens when C2 is greater than C1. When C2 is greater than C1, that reaction is spontaneous. Okay. So, in this way we can understand the concentration, electrolyte concentration cells. Okay. In the next video I shall come up with electrode concentration cells. Okay. If you really like this video, please if you really like this video, please comment, share and subscribe. Thank you. Thank you for watching.